On September 24, 2023, NASA's Osiris-Rex mission will etch its name in the annals of history by returning samples of the asteroid Bennu to Earth, concluding its 7-year journey through deep space. But before we start the video, please like this video, subscribe to our YouTube channel, and hit the bell icon so you never miss our next uploaded video. Let's start. Back in 2016, the Osiris-Rex spacecraft embarked on this incredible odyssey, eventually reaching Asteroid Bennu in October 2020, where it meticulously gathered samples from the asteroid's surface. The culmination of this remarkable voyage is set for September 24th, when it will bring these invaluable samples back to our planet. The return will be executed through a carefully designed capsule and parachute system, with the touchdown scheduled for 10 a.m. EDT, 1400 GMT, at the Department of Defense's Utah Test and Training Range near Dugway, Utah. Stay tuned for the latest updates on the approach, landing, and sample processing of this asteroid sample return mission. In preparation for the momentous event, the Osiris-Rex spacecraft underwent its final trajectory correction maneuver on September 17th, ensuring its precise alignment for the September 24th sample delivery. Currently hurtling towards Earth at a staggering speed of approximately 14,000 miles per hour, 23,000 kilometers per hour, the probe is about 1.8 million miles, 2.8 million kilometers, away. When it gets within a distance of about 63,000 miles, 102,000 kilometers, above Earth on September 24th, it will release a capsule containing the precious samples from asteroid Bennu. This capsule will descend into a specific target area spanning 36 miles by 8.5 miles in the Utah desert. Teams comprised of NASA and U.S. military personnel will be on standby, ready to recover this scientific treasure. The contents of the Osiris-Rex's descent capsule are no ordinary cargo. Inside lies a priceless sample collected from the surface of Bennu, a near-Earth asteroid with a diameter of 1,650 feet, 500 meters. This sample is anticipated to provide valuable insights into the history of our solar system. Curious about just how much material is packed inside? Find out more about the asteroid material quantity in NASA's Osiris-Rex probe in our detailed coverage. Astronomical surprises marked this mission from the start. When Osiris-Rex reached asteroid Bennu in 2018, the reality on the ground didn't match the expectations of mission planners. The rugged and loose, gravelly surface of the asteroid presented unforeseen challenges, prompting the spacecraft to undergo reprogramming to successfully land and collect the sample. Discover more about how asteroid Bennu confounded expectations and posed a near-death experience for the Osiris-Rex spacecraft in our featured story. With only a week left until the Osiris-Rex asteroid sample return capsule lands, the excitement and tension among scientists are palpable. This culmination marks the conclusion of Osiris-Rex's primary 7-year mission, commencing with its launch in 2016 and culminating with a collection of samples from Bennu in October 2020. As we eagerly await the impending landing on September 24th, NASA's preparations are in full swing. The spacecraft will brave re-entry into Earth's atmosphere, shielded by a heat shield, reaching speeds of up to 27,000 miles per hour before deploying drogue and main parachutes to ensure a more controlled descent at 10 miles per hour. The pictures were stunning, but why did Bennu's surface behave so unexpectedly? The answer involves cohesion, an attractive force that can bind molecules together. Cohesion gives water its surface tension and keeps droplets together even in a microgravity environment like the International Space Station. Granular materials like wheat flour, cocoa, and dust can also exhibit cohesion, which pulls individual grains into clumps. On Bennu, scientists had expected cohesion to act like a bit of glue between the rocks, making its loose surface more solid. But the TAG event showed that Bennu's uppermost layers are nearly cohesionless, deforming under stress like a fluid. A good analogy is a ball pit. Although the plastic balls are solid, they easily slide past one another and past boisterous children, behaving in mass like a fluid. Thanks to Osiris-Rex, We now know that Bennu's surface is not held together by cohesion, but by gravity, or microgravity. With a minute tug, less than 100,000 the pull of Earth. On the Moon, gravity is 16% as strong as it is on Earth, and more than 16,000 times stronger than it is on Bennu. As a result, loose material in the lunar subsurface is packed together more tightly, making the Moon's surface relatively firm. If a 50-kilogram mass of solid iron were to hit the Moon at the same speed as the TAG event, it would sink into the ground by only half a centimeter. Repeating this experiment at Bennu would yield a dramatically different result. Though the mass would strike with the same force, it would plunge 17 centimeters before stopping, over 30 times deeper than at the Moon. Bennu has consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. Using data from Osiris-Rex, we now have the ability to look back and accurately recreate 30 seconds on Asteroid Bennu. On October 20, 2020, Osiris-Rex made its final descent to a sample site called Nightingale. With its tagsome arm outstretched, it approached the surface at 10 centimeters per second, the walking pace of an insect. 1 second after contact, it released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the tagsome head for sample collection. 6 seconds after contact, while it was still sinking into Bennu, Osiris-Rex fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when Osiris-Rex had sunk nearly half a meter into Bennu, it reversed course and began to rise. At 16 seconds, the tagsome head re-emerged from the subsurface as the spacecraft continued to accelerate. 30 seconds after contact, Osiris-Rex shut off its thrusters and drifted away. With its sample of Bennu almost 6 months later on April 7, 2021, the spacecraft returned for one last flyover to observe its footprint at the point of impact was a new crater averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this tagged crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and then fallen back to the surface circled the crater like a campfire ring. With a puff of gas and an engine burn, Osiris-Rex had displaced 12 cubic meters of granular material, 6 tons of loose rock that may have been packed together as lightly as a bowl of popcorn. After a final departure maneuver in May 2021, Osiris-Rex began a 2-year journey back to Earth. Stowed on board were about 250 grams of Asteroid Bennu, a bounty of scientific treasure destined for future discoveries. And there you have it. If you have any question, drop them in the comment box below. And don't forget to like this video, subscribe to our YouTube channel, and hit the bell icon so you never miss our next uploaded video. We see you in the next video.